Welcome back. So in the previous lessons, we discussed bagging and we discussed how we can implement random forests from scratch, and we compared our implementation with the sklearn implementation, and we saw the difference and we saw how we can build the random forest and so on, right? Now, as we said, ensemble methods can be in two ways. Can be using bagging or posting. So given that we explained everything about bagging, now in this lesson and in the next lessons, we will explain what do we mean exactly by posting. So here, as you can see, this is a single machine learning model. So we have some data and then we fit this data in a machine learning model in one iteration and so on, right? So this is basically a decision tree, KNN, logistic regression, whatever, right? And then we have bagging, and we said for bagging we have different data sets, and these data sets are generated from the original data set using resampling with replacement, right? And for each data set we fit a machine learning model. So this is the first decision tree, for example, this is the second decision tree, the third decision tree, and so on. And we train these models in parallel, right? So we train them in parallel. For the posting, it's a different story, right? So as you can see here, this is the original data. We are not doing any resampling, so we use the full data set, the whole data set, and we train the first machine learning model, right? And as you can see, the size of the examples, so the size of the examples here is the same, right? So all the data points have the same size. Here, as you can see, the data points have different sizes. And after training for the first iteration or with the first machine learning model, we have different sizes for the examples and so on and so forth. So this is a sequential model. We are training them sequentially. Okay, so what do you mean exactly by this also? We will explain it better. So as you can see here, this is a single decision tree iteration, all samples. So we have x1, y1, x2, y2, x3, y3, x4, y4, x5, y5. We fit a decision tree using these examples, right? So this is a single decision tree iteration. For the bagging, we are doing something like this, right? So we have 3 inputs for the first decision tree, 3 inputs for the second decision tree, for example, 3 inputs for the third decision tree. And as you can see, x1 is used here and used here, x5 for example is used here and here, and so on. So parallel tree growing with subsamples, right? So we are using subsamples, and this should be the full 5 examples, but let's say we are using 3 examples only. Okay, so this is bagging. For posting, it's a different story. As we said, it's sequential tree growing. So we use different decision trees. So it's not one decision tree, it's multiple decision trees, but we are training the first decision tree using the full data set, and the examples have the same size. And then after that, we made some errors for x1 and x3, right? So that's why we are emphasizing the first and the third examples. Okay, so the second decision tree will take the same inputs but with different weights, and the same for the third decision tree, right? The third decision tree, after training the second decision tree on this data set, we found that we have an error from this example and an error from this example, right? So we will give more weight to this example and more weight to this example, and so on and so forth. So this is basically the idea of posting. Okay, so posting is basically giving weights to the examples that have more error, okay, or giving you more error. So in order to explain it even better, in the next lesson we are going to discuss ADA post. So ADA post is short for adaptive post. Okay, so this is one of the implementation of the posting algorithms, right? So in order to understand posting algorithms better, we will understand it by explaining ADA post, just like when we explained random forests, right? So in the next lesson, we will go and see how we can understand what do we mean exactly by ADA post. So let's go.